Hi, my name is Muhammad Hazwan, and these are my group mates, Kering, Cheng, and Lu Haoji. A sinusoidal function is a function that is like a sine function in the sense that the function can be produced by shifting, stretching, or compressing the sine function. Here is the example. As you can see on the screen, the blue line is the original function of cos, and the red line is the shifted function of cos, which is it shifted pi over 2 to the right. These are my friends, and I never thought I could make a sine graph with our heights. How amazing! Tangent function is periodic. They are vertical asymptotes at value of x where the function doesn't exist. It has no amplitude and no maximum or minimum values. Oh hey, it's me, and it's sine graph again. The sine graph is periodic. It has amplitude, maximum and minimum values. The graph looks similar to the cos function, however, it passes through the origin. On the other hand, the graph of cos function has the similarity with sine function, however, it never passes through the origin. From today's lesson, our learning goals are 1. To study trigonometric function, sine, cosine, and tangent. 2. To learn graphing and modeling with sine regression by applying to real life. For example, bungee jumping, because who doesn't love to enjoy seeing a beautiful nature from high above? But to be honest, it's not for me, because I'm scared of heights.
For our example, we're going to use a purple ball attached to a string at a certain point. So, please observe what am I going to do next. Obviously, I'm going to press the start button, if I can find the start button. Okay. So after I press start, you can see that the ball is moving up and down in random directions. But interesting enough, you can see the second graph forms a cosine graph. You can see the loop, not from the origin. If you want to create a graph first, you must have a range. So I chose a range from 0 to 10. Okay, but for each point, you must find the data. For instance, number 1, the data point is there, and for number 2, the data point is there, and for 3, it's over there, there, for other points. Okay, so all the there, these are the data points. After having all those data, you can now plot a table. So on the GC, you can find all the differences till L6. After that, simply enough, just press stat to press right to calculation and find sine regression. Whoa! You just found sine regression. After that, you just press enter. But for a quicker way, you can store the equation in one of those y's. So on store regression equation, press bars and to the right and store the equation in either of those y's. After that, simply enough, just press calculate, and here you go. That's all your answers. And here's the graph.
In this video, we will show you how does the value A, B, C and D affects the graph. A period is the length from one peak to the next. So both of these points determines the period. An amplitude is the height from the center of the line, which is this line, to the peak. Or we can measure the height from the highest to the lowest point and divide that by 2. A phase shift. A phase shift is how far the function is horizontally to the right of the usual position. So this part is our phase shift. Next, vertical shift is how far the function is vertically from the position. So this part is our vertical shift. Consider the equation y equals to a sine bx plus c plus d. We know that the amplitude equals to A, where the period is 2 pi divided by B. Next is the phase shift. It is negative C divided by B. And lastly, the vertical shift, which is the D. So, amplitude, period 2 pi divided by B, phase shift negative C divided by B, and vertical shift D. Let's try with an amplitude value of 2. So it's gonna be 2 sine x. As you can see, the graph gets narrow and taller, and this point, which is our maximum point, is y equals to 2, which is our amplitude value. Let's try another value, which is a smaller one, 0.5 sine x. Now the graph gets wider and our y value is 0.5. So next, what happens as our b varies? Say b equals to 2. So sine 2x. It shows that when b equals to 2, the graph has a period of pi, which is this part, and the next is 2 pi. Same goes to the negative part, which is negative pi, negative 2 pi, and so on. Let's try a negative value. Negative 2x. So here, the graph is reflected in the x-axis, but the period is still the same, which is negative pi, negative 2 pi, pi, and 2 pi. Let's try 0.5. The graph gets wider, where the period is 4 times greater than our previous one, which is sine 2x. This is, the green one is the value 4 pi for sine half x, while this purple one is our sine 2x. So the period is 4 times greater than sine 2x. Next, what happens as d varies? Say d equals to 2, so sine x plus 2. Notice that now our center of line is at 2, which is our d. Let's try a negative value. Say negative 1. Now the graph is reflected in the x-axis, where the center of line is now negative 1.
Tools previously to find the different effects of different spring constants. What will happen if the bungee cord have a low spring constant? Knowing that the total spring length is 1.14, we then know that the amplitude will start from 1.14 and it decreases as time goes by. The frequency of the graph will get lesser and lesser because it's losing energy. Observe it once more and we'll compare it to a higher spring constant. Knowing that a higher spring constant has a lower total spring length. So the amplitude will start at 0.5 and you can observe that the pendulum is moving left to right rather than up and down. The frequency in a given period of time is small compared to a lower spring constant. But the amplitude for the lower spring constant is higher than the amplitude of a higher spring constant. In conclusion, a lower spring constant will be more suitable for a bungee cord. Reason being, having a higher amplitude will give us more excitement, bouncing up and down rather than moving left to right, and having lower frequency, which means having less bounces, which will make us humans less dizzy.
Bring us everything we think we